Welcome to this lesson. My name is Tr Katimbo Richard, teaching mathematics. Our topic today is patterns and sequences. Our topic today is patterns and sequences. In patterns and sequences, we shall have to know and revise the types of numbers we covered right from P4. And here they are. The first one is whole numbers. Whole numbers are the mother to all the types of numbers. The question is, what are whole numbers? Or how are whole numbers derived at? Whole numbers are numbers that range from 0 to infinity. The example, or the examples to them are 0, 1, 2, 3, 4, 5, 6, 7, and so on. To reach the next whole number after 1, you go on adding 1 by 1. Hence, 0 plus 1, you get 1. 1 plus 1, you get 2. 2 plus 1, you get 3. 3 plus 1, you get 4. 4 plus 1, you get 5 in that order. So they have got that pattern of plus 1. Master this pattern for in P7, but being specific, from P6, we start applying these whole numbers. The pattern they follow, that plus 1 pattern. They go on adding 1 by 1. So, as we shall see later, after this revision of the whole numbers introduced to you in the lower primary, you must master this. Secondly, we have got natural numbers. Natural numbers are godly numbers, like you know the word nature. So they are godly brought. That's why I believe mathematics is heavenly. So they are also called counting numbers. When one is counting, as you are aware, we don't start from 0. We start from 1. So the first counting number is automatically 1. So the difference between whole numbers and natural numbers is just a 0. For whole numbers, as I've seen before, start with 0, whereas natural numbers start from 1. So that's the only difference. Otherwise, they go in the same way, apart from 0. So natural are also known as counting numbers. The examples are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. They also follow the same pattern. You go on adding 1 from the format to get a new one. Like 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, in that order. So master that pattern. We shall assess it in the application. Another type of numbers is even numbers. Even numbers are numbers that are exactly divisible by 2. That which, when divided by 2, somebody or one does not get a remainder. For example, 0. You know 0. When you have nothing, and try to divide, of course, there will be even. Nobody will get. So that's why 0 is an even number. So the next one is 2. The next one is 4, 6, 8, 10, 12, 14, 16, in that order. So these ones have got a pattern which is a plus 2. You go on adding 2 to get a new one. For example, 0 plus 2, you get 2. 2 plus 2, you get 4. 4 plus 2, you get 6. 6 plus 2, you get 8. 8 plus 2, 10, in that order. 12, 14. So you go on adding 2 to get a new one. So even numbers have got that pattern of +2. So when you come to application, you will go on adding 2. Odd numbers are directly opposite to even numbers. What are odd numbers? The answer is, odd numbers are numbers that are not divisible by 2. Remember, even numbers are numbers that are divisible by 2. So that's why I'm saying odd numbers are opposite to even numbers. That's why I'm saying odd numbers are opposite to even numbers. For the odd numbers are not divisible by 2. For example, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, that order. So, why do we take these ones to be odd numbers? I said they are not divisible by 2. So when I've got 1 divided by 2, of course, if everyone is to get a whole, nobody will get. Therefore, 1 remains undivided. So it is a remainder. Then we go to 3. 3 divided by 2, everyone gets 1. Then remainder 1. 5 divided by 2, everyone gets 2, remainder 1. That's why they qualify to be known as odd numbers. So odd numbers also have got a pattern of +2 like even numbers. Like 1 plus 2, you get 3. 3 plus 2, you get 5. 5 plus 2, you get 7. 7 plus 2, you get 9. 9 plus 2, somebody has mentioned it, 11, good. Then 11 plus 2, the next one is of course 13. Thank you very much. Another one, 13 plus 2, 15. Thank you, Nakato. So somebody goes on adding 2 to get the next one. So those are the odd numbers. So we shall take it that even and odd numbers have got the same pattern of +2. You go on adding 2 to get a new one. Please master the pattern each of the numbers, each of the types here has. We said odd numbers and natural numbers have a +1 sequence or +1 pattern. Even and odd numbers have got a common one of +2. You go on adding 2 to get a new one. Another type is prime numbers. Prime numbers have something to do with factors. Prime numbers have something to do with factors. What are prime numbers? Prime numbers are numbers with only 2 factors. With only 2 factors. Factors are also known as divisors. They are also known as divisors. So, what are the factors of a particular number? Factors of a particular number are divisors, like I've said, of a particular number. That when you multiply those numbers to lead to that number, those multiplied numbers are the so-called factors. For example, I've got 2. 2 has got 2 factors, 1 and 2. Not forgetting to mention that the first factor of a number is ever 1. Why? As you know, somebody can take it all. It's the common divisor for every number. Like now, if somebody is told to share some things, he may not share. He may decide to take it all. So he has taken it. So therefore, he has taken it all. So 2 divided by 1 is 2. So the first factor of a number is ever 1. And the last divisor or factor of a particular number is 2. Like 2 divided by 2, you get 1. So therefore, 2 is also divisor to 2. So the first factor of a number is ever 1, and the last one is ever that number. So prime numbers fulfill the law about factors. The first factor is ever 1, the last one is ever that number. So prime numbers have got just the rule, 1 and that very number. So the factors of 2 are 1, 2. Doesn't have any other factors. It's got only 2 factors. That is 1 and so. The next one is 3. It has got factors as 1 and 3. 5, 1 and 5. 7, 1 and 7. The next one, who can tell us? Good, someone mentioned it. It is 11. Why not 9? So 9 cannot be. There's a tendency of writing 9 after 7 in among prime numbers. So the tables or the divisors of that very 9 are 3. That is 1. That's 1 times 9, you get a 9. Meaning 1 is one of the factors of that same 9. Now we go to 3. 3 times 3 is a 9. So 3 is also a divisor or a factor to that 9, as well as itself 9. So it has got more than 2 factors, which are 3. That one qualifies to be called the next type, but it's not a prime number. So after 7, we have 11. It has got 1 and 11 as factors. 13 is one of them. So then it goes 17. After 17, we've got 19. Then among 20s, we've got only 2. That's 23 and 29. The rest are the other type we're about to see. So prime numbers are numbers that have got only 2 factors. That is 1 and themselves. Then the opposite of prime numbers is composite numbers. Composite numbers are those numbers that have got more than 2 factors. All those numbers that don't qualify to be prime numbers are composite numbers. The exceptional ones are 0 and 1. 0 is neither prime nor is it a composite number. Why? It has got only 1 factor. Whereas prime numbers must have 2 factors. Then we go to 1. 1 has got only 1. Therefore, it cannot be qualifying to be a prime number nor composite number, because composite numbers have got more than 2 factors. So from 3 factors, 4, 5 to infinity, those qualify to be called composite numbers. So the first one, of course, whatever is skipped here in among prime numbers qualifies to be, yes, remember, 0 and 1 are neither composite nor are they prime. So composite numbers, as I said, have got more than 2 factors. For example, 4. 4 has got 3 factors. 1, 2, and 4. That's why it's a composite number. 6 has got around 4. 1, 2, 3, and 6 itself. So those are the divisors to 6. Remember, 6 divided by 1 is 6. 6 divided by 2. Those divisors are the ones called factors. 6 divided by 2 is a 3. There's no remainder. 6 divided by 3 is a 2. And 6 divided by 6 is a 1. Therefore, it qualifies to be termed as a composite number. 8 qualifies in the same way. List down the factors of 8. Yes. Of course, 1. Thank you. Another one. Good. 2. 2 is the second factor of 8. The next one, 4. Thank you very much. Then another one is 8. So it has got 4 factors. That's why it qualifies to be known as a composite number. 9, as we said, the other side, is a composite number. Then 10, in that regard. After 10, good. 12, yes, I call, good. So after 12, 14. After 14, Rose, oh, thank you. After 14, you have got 15, and so on. All those are composite numbers. Good. Another type is square numbers. Square numbers are numbers got after multiplying a number by itself. Square numbers are numbers got after multiplying a number by itself. Now, what is to square? To square is to multiply number by itself. So square 1. When you square 1, that is 1 times 1, 1 gets 1. When you square 1, 1 multiplies 1 by 1 to get 1. So 1 is the first square. So 1 times 1 is 1. Then 2 times 2, 4. 3 times 3, you get 9. 4 times 4, you get 16. 25 comes from squaring 5. The next square is 6 times 6. 6 times 6. Oh, Mary. Good. That is 36. 36 is the 6th square. The 7th, somebody can guess? Yeah, many hands up. John. Good. The 7th square is 49. Then we go to the 8th square. That is 8 times 8. Ronald. 8 times 8 is not 16. That is addition. 8 times 8. Jessica. Good. That is 64. 64 is the 8th. Then the 9th. The 9th, that's 9 times 9. Who? Everyone guesses. Don't just guess. Put up a hand. I don't entertain chorus answers. 9 times 9, 81. Thank you very much. Then 10 times 10 is 100, like many of you have said. Then 11 times 11 is 121, 144. Should at least know the first 12. The first 12 squares. So that is 1. Good. Next. 4. After 4. Good. 9. 16. Good. 25. 36. 49. Good. 64. 81. 100. Aren't here? Good. 121. Then 144, and so on. So the first 12 squares are in that style. Remember I said square numbers are those got by multiplying a number by itself. Then I've got another category of numbers, which is cubic numbers. Cubic numbers are numbers got by multiplying a number by itself, but twice. But twice. There's a tendency of saying thrice. The multiplication is twice, but the number appears 3 times. So, for example, I've got 1. When you multiply 1 twice, 1 times 1 is 1. And again times 1, 1 gets 1 is cubed. Get 1 times 1 times 1. The multiplication appears twice. This is the times sign of multiplication operation. So therefore, remember in square numbers, we multiply once. The cubic brings another kind of multiplication. So we multiply twice, but the number appears thrice. So 1 times 1 is a 1. 1 times 1, you get a 1. So the first cubic number is a 1. The next cubic number is from 2 cubed. When 2 is cubed, get 2 times 2 times 2. 2 times 2 is a 4. A 4 times 4, 4 times 2, you get a 8. So 8 is the second cubic number. Then 3 cubed, like has been stated here, 3 times 3 times 3. So 3 times 3 is a 9. 9 times 3, you get 27. The third cubic number is 27. So do you continue in that category? We go to the fourth. 4 times 4, you get 16. 16 times 4, you definitely get 64. The fifth is 125 from 5 cubed. When 5 is cubed, you get 125. Why? 5 times 5 is 25. then 25 times 5 is 125. You continue in that regard, you make 6 cubed, then you get the next answer as 216. Then another category of numbers, triangular numbers. What are triangular numbers? Triangular numbers are numbers got by adding consecutive counting numbers. By adding consecutive counting numbers. Consecutivity means listing without omission. Listing that category of numbers without omission. As we have learned about counting numbers, that they are numbers got by adding consecutive, by adding 1, 1, 1 to the former number to get a new one. And the examples are 1, 2, 3, 4, 5, 6. This type of numbers gives rise to this other type, which is triangular numbers. For example, we have got 1 as the first one, then you go to 3 as the next one. How do you derive at the 3? You go on adding the next counting number. The first counting number is 1. You add on 1, you get 3. 3 you add on 2 other, you get 3. 3 plus 3, 1 gets 6. From this one, 1 adds a 4, that is 1, 2, 3, 4. Somebody gets a 10, that's 6 plus 4. 1 gets a 10. Then 1 adds 5 here because we are adding consecutive counting numbers. We are adding consecutive counting numbers. So we add on a 5 here. So that's 10 plus 5, you get 15. 15 in that order. Now you will be asked, find the next number in the next in this sequence. So you will definitely add a 6 and fill here. So you say 15 plus 6 and get 21. Remember, so 5 plus 6 get 11. 1 writes 1 and regroups 1 to the tens place value. 1 plus 1 you get 2. So that the answer is 21. So that regard is called your 2 marks in section A. Say find the next number in the sequence. So on the next, on this pattern below, so find, you get to know this is a type which is triangular numbers, and go on adding the next counting number to get the next triangular number. But triangular numbers have got another formula, or formula of how you can get them. For example, one would be asked to find the 50th triangular number. Find the 50th triangular number. So, of course, you may use this, but it's better to use a formula. They are the only ones that have got a formula when you have a question like this one. Find the 50th triangular number. You say that number into number plus 1. Then divide the result by 2. Number into number plus 1 divided by 2 is number 5 into that same number 5 plus 1, then divided by 2. So remember, into means times. So we say 5 times the sum, which is 6, divided by 2. We say when divided by 2, you get 1. Then 6 divided by 2, or gen, is a 3. So write a 3. Thereby getting 5 times 3, you get 15. So 15 is the 5th triangular number in that regard, as you see. Triangular number 1, 2, 3, 4, 5. We got it as 15 here, even reflecting the example 1, 2, 3, 4, 5. So instead of like using the pattern, the plus consecutive counting number pattern, someone can also use the formula to reach that number. So that is also good. Please use number into number plus 1 divided by 2. number into number plus 1 divided by 2. Then you answer that question. Now after all that, we shall look at divisibility tests also under patterns and sequences. Now we go to what is called divisibility tests. Divisibility tests. As you know, in mathematics, we must divide. We have all along heard people saying that number is divisible by 1. They go on dividing. You don't know why they have said it's divisible by a particular number. They use the divisibility test. We have people saying by 4, and for you cannot tell. So this is the idea they use to know how divisible a number is by the other. Now, in P6, you must have gone through the tests of 2 up to 5. As per P7, we start from the test of 6. But I'll drive you through the P6 one before we start off with the P7 one from here, the test of 6. Now, a question will be brought. They will say, without dividing, show if a number is divisible by the other. For example, part A, show if 112 is divisible by 2. You must know and have an idea of the test of 2. Like a number is divisible by 2 if the digit under the place value of ones is one of the first 5 even numbers. A number is divisible by 2 if the digit under the place value of ones is one of the first 5 even numbers. The first 5 even numbers are 0, 2, 4, 6, and 8. The first 5 even numbers are 0, 2, 4, 6, and 8. Like part A suggests, without dividing, show if 112 is divisible by 2. You are going to use the other idea that number is divisible by 2 if the digit under the place value of ones is one of the first 5 even numbers in this way. We say 112. We did mention about the place value of ones. In first term, we learned about the place values. Now here are they being applied. So we say ones, tens, hundreds. Our concern is the place value of ones. Which digit is under the place value of ones? Yes? Yes. Thank you very much. Say 2. Now, 2 being one of the digits, the same digits that are the first 5 even numbers, you can identify it in that way. You say, therefore, 112 is divisible by 2. Why does it qualify? Because 2 is one of the first 5 even numbers. We say that 0, 2, 4, 6, and 8. That's how we test. Meaning you don't divide. So somebody to cancel 112 by 2 or divide by 2, he uses that idea that a number is divisible by 2 if the digit under the place value of ones is one of the first 5 even numbers. Now we go to part B. Without dividing, show if 111 is divisible by 3. You will have to use the knowledge of the test of 3, of divisibility test of 3. A number is divisible by 3 if the sum of the digits is a multiple of 3. Remember, sum is the result after adding two or more numbers. So the digits involved are 1, 1, 1. A number is divisible by 3 if the sum of the digits is the multiple of 3. What you do is to test by adding 1 plus 1 plus 1, which is equal to 3. Remember, I haven't divided, but you have used the knowledge that a number is divisible by 3 if the sum of the digits is a multiple of 3. Is 3 one of the multiples of 3? Of course, yes. If yes, it means that you are going to conclude that therefore 1, 1, 1, that is figure 111, is divisible by 3. Then you underline it. So don't divide, but use the knowledge to test if that number is divisible by 3. Then we go to the division test of 4. This is a test of 4. What's the knowledge about the test of 4? One must know that a number is divisible by 4 if the figure formed by the digits under the place values of ones and tens is either a 0 or a multiple of 4. I'm repeating, a number is divisible by 4 if the figure formed by the digits under the place values of ones and tens is either a 0 or a multiple of 4. Now, they are saying test if or show if, that is without necessarily dividing, 400 is divisible by 4. So that said 400 is suited within the knowledge that a number is divisible by 4 if the figure formed by the digits under the place values of ones and tens is either a 0 or a multiple of 4. We talked of place values, therefore still locate the place values, ones, tens, and hundreds. Remember, we are interested in two kinds of place values, that's ones and tens. So you circle this one to identify the two, under ones and tens, under ones and tens. What's the figure formed by the digits under the place values of ones and tens? Yes? Oh, Jonah said it's 0. So which figure is formed by 2 zeros? Of course, it is a 0. And we said a number is divisible by 4 if, only if, the figure formed by the digits under the place values of ones and tens is a 0 or a multiple of 12. Now, I've come up with a 0, then conclude again. Therefore, 400 is divisible by 4. The same is applicable to 412. 412. So right here, our 12, like I've said, write ones, tens, and hundreds. Identify the figure formed by the digits under ones and tens. Everyone can see to the 12 is a 12, one with multiples of 4. Remember the multiples of 4 are Gen 4. Another one? Good, 8. Another one? 12. So 12 actually is the third multiple of 4. If it is among the multiples, like it has qualified to be, therefore we conclude that also 412 is divisible by 4 without necessarily dividing. So that's how we test for the divisivity of 4. I repeat, this is the knowledge you must use, that a number is divisible by 4 if the figure formed by the digits under the place values of ones and tens is either a 0 or a multiple of 4. So class, that's the test of 4. We shall go to the test of 5. Without dividing, show if 360 is divisible by 5. One must know how divisible a number can be by 5. A number is divisible by 5 if the digit under the place value of ones is either a 0 or a 5. Is either a 0 or a 5. A number is divisible by 5 if the digit under the place value of ones is either a 0 or a 5. Now the question has been brought to you. Show if 360 is divisible by 5 without necessarily dividing. So they're not in need of how many times it goes into 5, but knowing how divisible it is by 5. A number is divisible by 5 if the digit under the place value of ones is either a 0 or a 5. So therefore, write ones, tens, hundreds. But then 5, this is 0, you can underline that 0. Then you say therefore 360 is divisible by the required 5 and underline it. You have already tested without necessarily telling us how many times it goes. So 360 goes into 5. Likewise, without dividing, show if 365 is divisible by 5. You do the same. So if it's 365, automatically with 5 come here, and then you do it accordingly. So it's still okay to 1 tens and hundreds. Under ones, we've got a 5, and number is divisible by 5 if the digit under the place value of ones is either 0 or a 5. It is a 5 today. So you say, therefore 365 is divisible by 5, and you have finished that. You get your 2 marks in section A. So that's what you ought to have done in P6. So that's a reminder. Now in P7, we test from 6 up to 12. From 6 up to 12. So without dividing, test if, or show if 312 is divisible by 6. Last, when you are testing for 6, you must have learned how to test for 2 and 3. That knowledge is going to be applied to 6, because a number is divisible by 6 if it's also divisible by both 2 and 3. A number is divisible by 6 if it is also divisible by both 2 and 3. So now, show if 312 is divisible by 6. You test for 2. Test for 2. Remember, a number is divisible by 2 if the digit under the place value of ones is one of the first 5 numbers. You know them: 0, 2, 4, 6, and 8. So you say ones, tens, hundreds. You can either identify by underlining or you circle. So this is divisible by 2. It is divisible by 2. So you say divisible. It is divisible. 312 is divisible. You put on is so that the verb. So you say so that the verb is realized. It's divisible by 2. It's divisible by 2. Then you test for 3. You know a number is divisible by 3 if the sum of the digits is a multiple of 3. So you add them. Well, 3 plus 1 plus 2 is equal to 6. As we say, 6 is the second multiple of 3. Therefore, 312 is also divisible by 3. As it qualified in the tests of 2 and 3, yes, like I've said, if it qualifies for both 2 and 3, automatically is it divisible by 6. You say therefore 312 is divisible by 6. So this one doesn't have the specific one. It works within the test of 2 and that of 3. If it qualifies for 1 and doesn't go into the other, then it's not divisible by 6. It should be by both 2 and 3 like it has been here. We test for 2 and 3 and conclude for 6. There? Good. Okay, now we go to testing for 7. Testing for 7. Test if 714 is divisible by 7. This is what you must know. This is what you must know. A number is divisible by 7 if the digit under the place value of 1s. If the digit under the place value of 1s is doubled, and the result is derived from the figure formed by the remaining digits, leading to either a 0 or a multiple of 7. It's a lengthy thing, but still, you bear with me because you must know. A number is divisible by 7 if the digit under the place value of 1s is doubled, and the result is derived from the figure formed by the remaining digits, leading to either a 0 or a multiple of 7. Now, explaining that the application is very easy. Like now, identify ones, tens, and hundreds. Then the digit under ones is the one you are going to double. To double is to add itself or multiply by 2. Like now when I say 4 plus 4, you get 8. Likewise, twice 4, that's 2 times 4 is also 8. So you can multiply by 2 all default is solved. So you have doubled. So we're going to use addition as no multiplication, the same as we said addition. So 4 plus 4, you get 8. You have doubled the digit under ones. So the figure found by the remaining digits on the whole figure 714 is actually 71. You get 71 minus the 8. Then you subtract. You are going to borrow because 1 minus 8 is only possible after borrowing. We are borrowing base 10. The 10 plus 1 is adding 11. 11 minus 8. 11 minus 8 is 11 minus 8. What does 1 get? Please, it is a 3. It is a 3. Then you get a 6. A 6 is a 63. A multiple of 7 is a 63. A multiple of 7. Yes. So someone has already found out. 63 is a multiple of 7. Therefore, you say 714 is divisible by 7. It's a lengthy thing, but the application is just easy. Double the digit under ones. Subtract the sum from the figure from the remaining digits, which were not doubled, that's 71. 71 minus 8, 1, you get 63. 63 is the 9th multiple of 7. And you conclude that 700, or the given number, is divisible by 7, like it is here, that 714 is divisible by 7 in that regard. Then we test for 8. We test for 8. While testing for 8, again, you must know that a number is divisible by 8 if the figure formed by the biggest under the place values of ones, tens, and hundreds is either 0 or a multiple of 8. Like we've got 4,016. You say ones, tens, hundreds, and thousands. We are interested in 3 of them, ones, tens, and hundreds. In that regard, what's the figure formed by the biggest under ones, tens, and hundreds? Yes? Oh, Joseph, good. It is 16. Now, if so, then is 16 a multiple of 8? Good. Definitely it's the second multiple of 8. Then if it is a multiple, you say 4,000. Therefore, 4,016 is divisible by 8. So what are you using to know the test of that 8? You say a number is divisible by 8 if the figure formed by the biggest and the place values of ones, tens, and hundreds is either a 0 or a multiple of 8. Now, it has brought a multiple of 8, which is 16. Had it been 4,000, still would conclude that it is divisible. Why? The figure formed by the biggest under ones, tens, and hundreds would be a 0 then. So today it is a 16, it's the second multiple of 8. So that's why it has qualified to be divisible by 8. Then we go to the test of 9. 9 is tested like that of 3. You say without dividing, show if 243 is divisible by 9. A number is divisible by 9 plus if the sum of the biggest is the multiple of 9. If the sum of the biggest is the multiple of 9, it's like that of 3, number is divisible by 3. If the sum of the biggest is the multiple of 3. So what you do is to test like we did that of 3. We say 2 plus 4, then plus 3. You add actually, what's the sum here? 9. It has brought a very 9, which is the first multiple of 9. You say, therefore, 243 is divisible by 9. If it doesn't bring a 9, for example, if it had brought 10, you would say, therefore, 244 is not divisible by 9. So not only shall we get the one now bringing the test, but these ones are set in that category today. They are all qualifying to be divisible, so that if it's not divisible or it's not within that rule, please, you say it's not divisible. Today, this is divisible because the first multiple of 9 is 9, and therefore, we conclude 243 is divisible by 9. Now, we go to 10. That is very easy, and I think the easiest. Test whether 210 is divisible by 10. You must know that a number is divisible by 10 if the digit and the place value of 1 is a 0. A number is divisible by 10, you go together. A number is divisible by 10 if the digit and the place value of 1 is a 0. Like now, I've got 210. 210. What's under 1s? Show the place values. It is a 0. It has qualified automatically. You say, therefore, you underline this one to show that you are testing by the place value of 1s. And you say, therefore, 210 is divisible by 10. After that, we go to the 11. 11 is as technical as that of 7. Testing for 11 is as technical as that of 11. We've got 6, 9, 2, 3, 4. Without dividing, show if 69,234 is divisible by 11. Plus, you must know that a number is divisible by 11 if the difference between the sum of the digits in the odd and even places is either 0 or a multiple of 11. I repeat, a number is divisible by 11 if the difference between the sum of the digits in the odd and even places is either 0 or a multiple of 11. What do we say? This is about placement, not the actual numbers being even or odd. This is place 1, place 2, place 3, place 4, place 5, place 1, place 2, place 3, place 4, and place 5. So what you do, this is odd place, even place. Odd place, even place. Odd place, like that. The number is even, but the place is place number 1. So it is an odd place. The second place is even place. The third is odd in that category. So what you do is to identify the said places. 1, 3, and 5. Place 1, place 3, and place 5 are odd. Are odd places. Are odd places. Not odd numbers, but places. Now, place 2 and 4 are even places. Are even places. Here, the numbers may be like 9 and 3 are actually odd numbers, but the placing or the placement or where they are in that particular figure is what matters. Second place, and this is the fourth place. So place 2 and 4 are even places. So what you do is to add those odd places and even places. So get the sums and subtract. You say 6 plus 2 plus 4, those are odd placed digits, minus 9 plus 3. Add very well. 6 plus 2, good. That's 8 plus 4, you get 12. So 12 minus the sum of 9 and 3, which is actually 12. The difference between the sums of odd placed digits and even placed digits is at 0. So now that has brought a 0, we say it should either be a 0 or a multiple of 11. If it has brought a 0, you conclude and say, therefore, 69,234 is divisible by 11. If you had brought the multiple of 11, it will also work. So like 11, 22, 33, like that. But now it has brought a 0, which is within the rules. So now we go to 12, which is the last. It's also very easy. Test if 612 is divisible by 12. Test if 612 is divisible by 12. A number is divisible by 12 if it is also divisible by both 3 and 4. By both 3 and 4. So that one also is tested like 6. You must have tested for 3 and 4 to test for 12 automatically. So I've got 612. You first test for 3, that is 612. 6 plus 1 plus 2. Thereby getting 6 plus 1, good. 7 plus 2, you get 9. Is 9 a multiple of 3? Yes. So 612 is divisible by 3. That means that the answer has been reached. We have so far tested for 3. We test for both 3 and 4, and then we conclude. So then we go to testing for 4. A number is divisible by 4, remember? A number is divisible by 4 if the figure formed by the digits under the place values of 1s and 10s is either 0 or a multiple of 4. So we say 1s, 10s, and 100s. The figure formed by the digits under 1s and 10s is a 12. Is 12 a multiple of 4? Automatically, good. If it is a multiple, then say also 612 is divisible by 4. So now the question is 600 divisible by both 3 and 4? Good. Everyone is happy now. Good. Now our test has qualified automatically. So 612 is then therefore divisible by the required number 12. Class, that has been our lesson today. My name is Tr Katimbo. Katimbo Richard. So, as you took that work, you need to go through as you work out. Thank you for being such a good audience. My contact number is 0776 251655 for any inquiries. Thank you very much for being such a good audience. We'll meet next time.